So in this video, I'm just going to go through a couple of common terms and definitions and a few small examples of things you might see when you're talking about polygons or talking about angles in a basic polygon unit. So the first definition I want to go over is an adjacent angle. Let's go with this color. An adjacent angle. And an adjacent angle is any angle, any two angles that share a ray, right? So they're two angles that share a ray. Okay. So for example, if you have a set of angles, let's say we had this angle here. Let's make this another color too. Let's say you had this line and then you had this line, right? And you could say that in the middle, right? If we had two angles, right, we could say that this angle right here, and then we can also take this angle right here and place them next to each other, right? You place them right next to each other. You see that they share this ray. They share this ray right in the middle, right? So you can see that they are essentially the same side, and that makes them adjacent. They're right next to each other. And sometimes you actually have these angles that I'll show you later called complementary angles, and those are always adjacent as well, complementary and supplementary. Okay, so adjacent angle is your first definition. Your second definition is a complementary angle. Complementary angle. Okay, and complementary angles, okay, adjacent angles and complementary angles. Complementary angles are always 90 degrees. Okay, so they're the sum. So the sum of two angles has to be 90 degrees. Okay, so if you want the angles to be complementary, they have to have a sum of 90. So for example, if we want two angles that make 90 degrees, right? You take a right angle, like this, and we can draw in our right angle like that. And then let's say we broke this up into two different angles, right? So we break it up and we'll say that, maybe this angle here, maybe this angle here is I don't know, let's say 35 degrees, right? We can say that this angle here, we'll say A, B, C, D. So angle ABD is equal to 35 degrees. And then let's say that the angle DBC, right? Angle DBC, if we didn't know the measurement of this angle, right? If this is going to be 90, 35, right? 35 plus what? 35 plus what is going to give us 90 degrees? Well, if we take 90 and we subtract out 35, right, we're going to get 55, right? So 55 degrees. In order for these to be complementary, if you add these two together, you're going to get 90 degrees, okay? Or our right angle here, or angle ABC. So those are complementary angles. You also might get a scenario where things add up to 180 degrees, and we call those supplementary angles. Supplementary angles. And this is when the sum of the angles sum of really angles is 180 degrees, or a straight line, right? So if we think about a straight line, we know that that's 180 degrees. And any two or more angles, right, that add up to a certain amount of 180 degrees in this case will make them supplementary to each other. So let's say that this angle right here, let's say that that was, let's say this was 60 degrees, and then the whole angle has to be 180, right? This whole thing is 180, so the other side has to be 120 degrees for them to be supplementary. Okay. Now, let's say that the angles are the same, right? Let's say that I draw the angles like this. Let's say I draw a line like this. Let's draw two supplementary angles. And let's say that they're both right angles. Okay, let's say that they're both right angles. Right? We've got 180 degrees, they're supplementary, and they're both right angles, right? That means they're equal to each other. When two angles are equal to each other, that makes them congruent. We call that congruent, okay? So if you've got two angles that are the same, that makes them congruent. It's equal. Equal angles. Equal angles. And you can also have equal sides too. If you have the same side as well, you can say that those are congruent. Okay. So in this case, they're both congruent. And normally you would denote that with either like a dash or some kind of a curve, right? So, we can imagine that these two up here might be the same size. So we would label them like that to show that they're the same, okay, in a figure. Okay. Now let's say that instead we're talking about a set of angles, right? Let's take something that looks like this. Let's say I draw a line here, and then I draw a line here, right? And we got two lines like this. They're crossing each other. They're intersecting. They're not necessarily perpendicular. We'll call this angle 1. We'll call this angle 2, angle 3, angle 4. Okay. And we have a relationship here. There's a relationship here that in geometry can help us kind of do some detective work and try to figure out the size of the angles. Okay. And one of those is that when two angles are across from each other like this, so 1/3, right? When two angles are across from each other like this, we call them vertical angles. Okay. We call those things, call that relationship, those two vertical angles, okay? All right, and those are across from each other, but one of the ways that we can describe that also is saying that the two angles, right, if they're vertical angles, right, they are talking about angles that are essentially sharing a vertex that are directly across from each other, and they're also going to be congruent. Okay, so angles across from one another, and those two angles are always congruent to each other. Okay, so they're congruent to each other. So we know that 1 and 3, okay, 1 and 3, angle 1 and 3 are congruent. We also know that angles 4 and 2 are congruent to each other. Okay, because they are across from one another and they share the same vertex right here in the center as well. So those two are also congruent to each other. Okay, so those two are vertical angles. You also get, you can see here that you've got this 180, right? You've got two adjacent angles to supplementary adjacent angles between 4 and 1, 4 and 3, 3 and 2, 1 and 2. Okay, so you can see that this relationship is there as well. All right. Now, let's say that you had instead of lines, you had a triangle. Okay, so I'm gonna do my best to draw a triangle here. So let's say we had a right triangle. Let's make this a right triangle, like that. Okay, and we'll make him a right triangle, and let's call this one triangle EFG. So this is triangle EFG. Okay, and what are the different labels or terms in here for a triangle as well? Well, there's a couple of things, especially in a right triangle. When we're using things like Pythagorean theorem, and we're using things like sine and cosine and all that stuff, you need to have kind of labels for them. And one of the labels that you might see is that these two sides, side EF and side FG, are called legs. They make up the right angle. So legs, or at least legs maybe of a triangle, legs of a triangle. Okay. Legs of a triangle are the sides of a right triangle that form the right angle. That form the right angle. Okay, so in this case, side EF and side FG, okay, are our legs. Okay, and then we also have side EG, right? We'll use this color, right? We have side EG, and this side is also mostly our largest side. We're pretty sure it's our largest side, and we call this guy the hypotenuse. Hypotenuse. Okay, call that the hypotenuse. And the hypotenuse is always the longest side of the triangle. Longest side of a triangle. And that's because when we use things like, again, Pythagorean theorem, right, you have a squared plus b squared equals c squared. We need to denote which ones they are. And typically, a is going to go right here, b is going to go right here. And our longest side is usually c, because the two are going to make up the sum, at least the sum of their squares are going to make up the square of this side. So we call that the hypotenuse. Okay. Now let's say that we drew another triangle. Let's say I drew another triangle and I made it look like this. Say we did that. So we'll make him here, make that one there, and we'll draw a line there. And say we labeled this EFGH, and then I, and then J. We'll say we did that, and we'll say that this is also a right triangle. Now, something that's interesting about these two shapes is we can see that they are kind of closely related, right? They look almost the same. We call shapes like this similar figures. Okay, there's a term in there that we call similar figures. Similar figures. And similar figures are shapes that essentially look alike, but they are proportional. They have proportional sides, They're proportional to each other. So side A should be proportional, well, at least the fraction of side A to, let's say, side D, A, B, C, D, E, and then F, right? Let's say we had side D, E, F. A over D should be proportional to, A over D should be proportional to, say, B over E. B over E, because they match up. Okay, they should be equal to each other, and this should also be equal to C over F. Okay, so they should have proportional sides, which means that their fractions are equal, and they should also have congruent angles. Okay, so if it's a similar figure, if these are actually similar figures, that means that angle E should be the same size or same degree measurement as angle H. Obviously, we have two right angles here for F and I. And then angle J should be congruent or equal to angle C. Okay. And those are the different kinds of things that you're going to see in geometry.